First thing I'll say about it is there are 4 questions, and I'm only showing one of them right here. And the first question is, for this question, please draw the Lewis structure of C2H4. If you successfully draw it, then type yes into the box. Typing yes into the box will award you the points for this question. You are on your honor to complete this question. And if you cannot successfully draw the Lewis structure for this problem, please rewatch the lecture outline video or see me in office hours for help, or of course, ask questions about it right now as we go through it. Now, the list of guidelines for making Lewis structures, and by the way, this is probably one of the most important things we're going to be doing certainly this semester and certainly for the rest of this semester, because everything else we're going to be doing more or less depends on knowing how to do Lewis structures. And we'll do plenty of them. They'll be like limiting reactant problems, right? They're challenging at first. We'll do 50 to 100 of them, and by then, hopefully, we will feel comfortable. Now, for the Lewis structure for C2H4, I'm going to go over the steps I went over in the lecture outlines about how to do them. The first thing you do is you count up the valence electrons. And for each, let's do this in green, I guess. For each carbon, can anybody tell me how many valence electrons a carbon atom has?
Four.
Thank you. 4. And that comes about because on the periodic table, so it's, so for carbon atom, 1s2, 2s2, 2p2 is its electron configuration, and the valence electrons are the electrons with the highest value of n, where n equals 2 here, and there are 2 plus 2, or 4 electrons. And the other way to determine valence electrons is if you look at carbon's position in the periodic table, it is in group 14 or group 4a, and in either case, that number 4 tells you how many electrons there are. Arinse, glad you could make it. I'd love to hear more about it later on. Now, there are 4 valence electrons per carbon, and there are 2 carbons, so it's going to be 4 times 2. And then if you look at hydrogen, it has 1 valence electron, and there are 4 hydrogens. So we end up with 4 times 2 is 8, plus 4 is 12. And there are 12 valence electrons. And we'll do more examples in the future where there are charges, but this has no charge, so there's nothing to adjust this to. So we have 12 valence electrons. Then the next step is to put the least electronegative atom in the center. And for electronegative, I'm just going to use capital E, capital N. Least electronegative atom in center. Hydrogen can never be in the center. And the reason hydrogen can never be in the center is because hydrogen only ever wants 1 bond. To be in the center, you need 2 bonds, so that's why. And there's one thing that is not in the guidelines that we are going to use for this one, and so I'm going to add that here. If there's more than 1 carbon, bond the carbons together. If there's more than 1 carbon, bond the carbons together. And I'll give myself some more space here. There we go. So what I mean by that is bond the carbons together. Each dash is 2 of those valence electrons. And then I'm going to put 2 hydrogens on each of the carbons, and I'm going to put those with single bonds, where each of these dashes is 2 of the electrons. So if I count them up, I have 2, 4, 6, 8, 10 electrons in here already. I only have 12 electrons to put into this entire Lewis structure. So I only have 2 electrons left. And when I look at this carbon, the goal for each carbon, each atom really other than hydrogen, is for it to have an octet of shared electrons. And we said that having an octet of shared electrons, that's what's called the Octet Rule. And what we will see is that the Octet Rule rules all Lewis structures, that we will have more to say about that. So when I look at this carbon and I only see 2, 4, 6 shared electrons, and I look at this carbon and I see 2, 4, 6 shared electrons, I could place the last pair of electrons on either carbon. I'll place them right there. But there's 2 things. We can only put 12 valence electrons in, and we want each carbon to have 8 valence electrons shared. So let's see, put a least electronegative atom in center. I guess technically I've already done step 3, which is draw dashes as single bonds. Each dash represents 2 shared electrons. And I can't remember exactly if this is step 4 or 5, but I think the next thing is going to be complete octets by forming double and triple bonds. And as far as forming double and triple bonds, you'll always form as many double bonds as possible before you ever form triple bonds, as we will see. And what this looks like is I have a pair of electrons here. And so this carbon has an octet. This carbon does not have an octet. So I'm going to move these electrons over to form a double bond. And then I'll actually do it over here because that's the only space I have left on this page so that you can still see everything. But it will look like this. As a final Lewis structure, because I took these 2 electrons, moved them over, formed a double bond. And this Lewis structure meets all of our requirements. It has 2, 4, 6, 8, 10, 12 electrons. That's all the electrons we can put in here. And each of the carbons has 2, 4, 6, 8 valence electrons around it. The carbon has 8 valence electrons as 4 bonds, 4 shared pairs of electrons. And you can see that the other carbon has the same thing. So this is our final answer. And this is actually, in this question, these are sort of basic Lewis structures. So that's why you only have to say that you can draw them. It's a good practice. Please do it. You'll get the points. And what we'll see is that in the other questions, we're moving on to more advanced Lewis structures that still fall within this basic set of guidelines for making them. Excuse me. Are there any questions about that?
Please, can you zoom the whole paper, please?
Can I zoom out? Yes. I assume you want me to zoom out so you can see the whole paper. Is that right?
Yes. Thank you.
Yep.